Okay, let's take a look at another example. In this one, we're looking at proportions. And so if we have proportions, if we meet certain criteria, which I'll show you on the next slide here, then we can use proportion data with z-scores to come up with these probabilities. So if we find out that at St. Andrews College, 72% of all students want on-campus housing, if we want to know the probability of a sample of 30, so if let's say we have 30 incoming freshmen, and those individuals, we know the probability of the proportion of those students being between 67% and 77%. What's the probability of that occurring? We can calculate using z-scores. But the way we have to first figure that out is, do we meet the criteria to use z-scores? And these two formulas must be more than 5. So the population proportion is 0.72 times the sample size. That is larger. And then 0.28 times 30 gives us 1, and it's still larger. So this is just a checkpoint to make sure that we do have a large enough sample to use proportions and z-scores together. So now what we have to do, if you think about it, we've always had to take a sample something minus a population divided by standard error. So how do you calculate standard error? Standard error is a pretty easy formula. Now I'm going to show you it up here because I think it'll be a little bit easier. But you're going to take the population, draw a nice one here, population proportion times the complement of the population proportion, divide that by 30, and then take the square root of that, and you get that 0.082. So that's where that 0.082 comes from. That then becomes the denominator of our z-score calculation. And when we do that, we end up taking 0.77 minus 0.72 and then divide by standard error, and that's what gets us at 0.61. So the z-score at this point is 0.61. Okay, what do we do with that 0.61? We look at our table, we go down to 0.6 over to 0.01, and we get a probability of 7291. As you see up there. And that's where you can find that probability. Do the same thing for the 0.67. And of course, you're going to get the same z-score, just going to be negative. And the probability that corresponds to that is 0.2709. And as you see, that's what it should look like up there. I'll leave that there. So that, again, was 0.709. Which means to find this area, I'm going to take 0.7291 minus 0.2709. And on the next slide there, it'll tell us what that answer is. There we go. So 0.7291 minus the 2709 gets us 45.82%. So there's a 45.82% chance that the proportion of students out of the 30 that want campus housing that it's between 67 and 77% is that 45.82%. So that's how you do a population proportion and compare it to a sample proportion to come up with a value. You can, for any, now I'm showing you just for one on each side. If I just want to know the probability of it being more than 77%, then all I'm going to do is take 1 minus 7291, and that gives me my correct answer, and so on. So I don't have to do this for two different values, one on each side. All I'm doing is finding a z-score, finding the probability that goes with that. The difference being, instead of standard deviation, we're using standard error, and it's either a sample proportion compared to a population proportion, or it's a sample mean compared to a population mean. And that's all we're really trying to focus on for Chapter 7.